choose to torch weld, torch welding is super persnickety. Everything seems to matter, like the torch tip size, the pressures with that size. That's where the low pressure oxygen regulator can really help. The flux that you use has to be fresh and can't be contaminated with anything like you know, some tap waters will not work. Mineral water is the best, spring water, something like that. It's very touchy with regard to the temperature. If you just paint it on and swoop in there and try to weld it, it will, the flux will jump off. But if you can get it hot ahead of time and paint the flux on, then it will stick. I TIG welded the ends of this seam to keep them from back cracking, and then so I wouldn't have to weld all the way out to the edge with the torch, which of course can be done, but it's just a lot easier if you weld your ends first. I put flux on the back side of the seam. There we go. I'm also going to flux my filler rod. I've had good luck with a couple of different fluxes, Amco 22 and anti-borax number 8. The anti-borax number 8 was the one the old IndyCar builders used to use way back in the day. That's the way that looked. So I'll just do a little bit of the seam. I'm going to start on the edge of where the tacks from the edge of the panel stop. Trying to sneak up on it a little bit. Actually, I'm going to turn my torch down. I'd cranked it up to heat up the panel. Aluminum is very touchy with regard to your torch temperature. I think that's probably the most, well, getting the metal clean is the most important thing, but then the next would be controlling the temperature of your torch, because the aluminum wants to oxidize so badly that it really makes it a challenge. And it doesn't change color either as you go to weld. It just, the surface just kind of rises up a little bit. Might need to make my torch a little hotter, but I don't want to get it too hot. I realize it probably doesn't translate that well because of the flux. Makes it kind of orange. Okay, probably need to adjust my torch. I'm reluctant to heat and stop and reheat because my panel is likely to oxidize more the more I interrupt it. Okay, torch isn't hot enough. All right, just got to do it. A little bit more. Of course, that's not something you want to breathe. I just added more acetylene to that flame. Oh, there we go. Now we're talking. If you can do it in one fell swoop, that's going to be better, just because you'll get less oxidation trouble. I can tell I'm getting a little bit of oxidation because my puddle is not as fluid as I would like. It feels just a little chunky. And that could be if I didn't clean the panel well enough. There may have been some Dykem left on there. I did scrub it with a stainless steel brush and everything, but it's just hard to get everything cleaning up. I'm going to clean that off and just so we'll have something to look at there. The flux is really corrosive, and you definitely don't want to leave any of that on your panel, or you'll have paint lifting problems later. That weld is a little bit cold. I felt like it wasn't really flowing in and flattening out like I would like, but before I keep going, I can clean that up some more. There we go. Yeah, I would like for that to be penetrated further into the metal. It's a little bit cold, kind of sitting on the top. I turned up the heat and put some more flux on there and kept going. It worked okay. There are a few little imperfections in there that I'm not thrilled about, like that one right in the center. Let's see if I can find that little guy right there. And there's a little bit more of that kind of funkiness in there. That could be from I used the water out of the refrigerator from the drink dispenser, the drinking water dispenser. We have a water softener. That could be the problem. Literally, if the slightest imperfection, it will contaminate your flux, like if the flux is old. Anyway, this will work all right. I think I can planish that out and it'll be all right. Here's the torch setup I'll be using to weld this together. It's a pretty standard Victor equal pressure torch. I've got a 0 size tip mounted on there. The material that I'm working with is 63 thousandths thick. I've noticed that aluminum is very, very particular about the size of torch that you're using and the way that it's set up. That would include everything from the distance and speed that you're moving from the panel to the pressures that you use and so forth. One thing that I will put a good word in for, because I know it makes it a lot easier, is a low pressure oxygen regulator. So for example, the typical oxygen regulator that you get, the first number that registers on the dial is 20 pounds per square inch. With a low pressure gauge, here you can see 5. With the pressures that you use for most torch welding, you're usually in the 3 to 5 pound range. That really gives you a lot more controllability with your flame, which is going to make a huge difference, especially on aluminum. It's just so easy to get it too hot that it melts, and it's a disaster.